Hello everyone, I am Vishwas Sundrani, Assistant Professor, Department of Mathematics, VNR VJIT, Hyderabad. So today I am going to present some application of differentiation and some foundation and key concepts. We will see how differentiation and differential equations are applicable to real life problems. So we will see some basic applications and how before, and if you want to apply the application of differentiation, you must have the knowledge of its foundation and key concepts. So we will see some basic definitions also, some examples also. Okay, I'll start. So very first application we will see what are maximum and minimum values. So some of the most important applications of differential calculus are optimization problems. We want to optimize in real life. Suppose if you own if it is your own company and you want to maximize your profit, then in that scenario our knowledge of differential calculus comes in the picture. Suppose you want to hire some employees, suppose 8 employees you needed for 8 different tasks. What you will do, for each task every employee can work, and but it charges different money for different tasks. So how you will assign different employees to different tasks? It will, what you want to do, you want to minimize your cost. You want to hire the employees in such a way that your cost will be minimum. In such a case mathematics plays important role. Okay, so here we will see what are maximum and minimum values, what are the applications. So one more application is if you have a company which manufactures some can, and can is the storage for some water or cold drinks. So you want to decide the shape of a can in order to minimize its manufacturing cost. So this is one of the minimization problem. So if you minimize your manufacturing cost, it will benefit your company, it will benefit someone's company. Okay, in space technology also differential calculus plays important role. If you want to calculate the maximum acceleration of spacecraft, so this is very important question for an astronaut who have to withstand the effect of acceleration. So in such scenario knowledge of differential calculus, application of differentiation will play a important role. So what are these absolute and local extreme values? We will see. So what is absolute maximum value of a function on some domain? If f of c is greater or equal to f of x for all x in domain, then we say that f of c is the absolute maximum. And if f of c for some c in that domain is less or equal to f of x for all x in that domain, we say that f of c is the absolute minimum value of that function. Okay, if I draw a graph, it will be clear. Okay, this is a function in some domain. So where is the maximum value of this function? It is somewhere here. Okay, so corresponding to this point on x, we got the maximum value here, and minimum value lies somewhere here. So this is the point for which all functional values are lesser than this value, and all functional values are greater than these values. This is absolute minimum and this is absolute maximum graphically. Now how local maximum and local minimum is different, that we will see. Local maximum value of f of a if f of c is greater or equal to x when x is near to some c. Okay, it is defined in some neighborhood of c. In some neighborhood of c, f of c is greater or equal to f of x for all x belongs to the neighborhood of some smaller neighborhood of c. And local minimum value of f of c is less or equal to f of x when x is near to c. Graphically, if you see, if I draw this type of graph, you can see this is local maximum in this neighborhood, in this small neighborhood. This is local minimum in this small neighborhood. So this is the minimum value inside this neighborhood. Okay, what is the neighborhood? X neighborhood. This is the neighbor corresponding to this x. These are the values, and this is the local minimum. And corresponding to this x values in this interval, this is the graph, and this point is the local maximum in this neighborhood. So local maximum and absolute maximum are different concepts. Now we'll see what is extreme value theorem. Why we are seeing this basics? Because in order to apply any concept, you must have knowledge of all these things. So what is extreme value theorem? So if f is continuous on some closed interval a b, then f must attain absolute maximum values f of c to some where c lies in a b, and it attains absolute minimum f of d at some number d in a b. So if your function is, let us say, continuous function, if I have some continuous function like this, okay, where is the absolute maximum? You can see here is the absolute maximum. This is point A, this is point A, and this is point B. So our function is defined in this AB. Okay, so we have this function is continuous, so we are able to find a point in AB where function has absolute maximum. Okay, and this is some point C, and we are able to find some point in AB where your function attains absolute minimum. So this is point D, and this is what f of C, and this is C, and this is some f of D. Okay, so this is the extreme value theorem. Next, Fermat's theorem, what it says: if your function attains local maximum or local minimum at some point C, then definitely if f dash C exists, then definitely f dash C is equal to 0. So if your function has local maxima or local minima at some point C, at that point if the derivative exists, definitely it must be 0, because if you draw a tangent line to that point, it is parallel to the x-axis. So now what is critical number of a function? A critical number of a function f is a number C in the domain of f such that either to that point f dash C is 0 or f dash C does not exist. We'll see some example. So in order to find the critical number of f of x, you have to differentiate it. So if I differentiate f, what I will get? F dash x is equal to what? 3x square minus 6x. So where it is 0, we'll see. First of all, this function is differentiable everywhere. Okay, so there are no points where it is not differentiable. Now we can find the critical number by equating it to 0. So we will see where it is 0. So this is 3x into x minus 2 equal to 0. So what I will get? X equal to 0 and x equal to 2. So at these points your function's derivative is 0. So what we got? Critical numbers are, so critical numbers are 0 and 2. Critical numbers are 0 and 2. Okay. Now we will see the closed interval method to find the absolute maximum and minimum values of your continuous function. Okay. So what does closed interval method says? First you have to find the values of f at the critical numbers of fa. So first of all you have to find the critical numbers. You have, by differentiating the function, you have to check where the function is not differentiable, and you have to check where the functions have zero values for the differentiation on that domain. So after finding the critical numbers, you have to check the value of the function. You have to find the value of that function on that critical numbers. Next you have to find the values of f at the end point of the interval. What are the end points here? A and B are the endpoints. So basically you have to find the functional value on the critical numbers and on the endpoints. So you have to compare all the values. The largest among the largest values of the step 1 and step 2 is the maximum value, and the smallest of these values is the minimum value, absolute minimum value. So with one example it will be cleared. What you have to do, we'll see. So that this example is given. So how to find the absolute maximum and minimum values with the closed interval method? First I will differentiate this function. So what is f dash x? So f dash x is 3x square plus 6x. So now you see that this function is differentiable everywhere. At no point it is not differentiable. So we cannot find critical number by that. So how you can find the critical number? Equate it to 0. See where it is 0. So where it is 0, 3x into this is x plus 2 equal to 0. So what I will get? X at what x it is 0? At x equal to 0 and at x equal to minus 2 it is 0. So these are the critical numbers. And what are the end points? X equal to minus 1 by 2 and x equal to 4. So at all these points we will find the functional value, that is f of x. So what is f of 0? You see f of 0 is 1. Okay. And f of minus 2, what I will get? F of minus 2 is minus 2 cube, which is minus 8, plus 3 into minus 2 square, which is 4, plus 1. So what I will get? Minus 8 plus 12 is 4, 4 plus 1, which is 5. And next is f of minus 1 by 2. So what is f of minus 1 by 2? It is minus 1 by 8 plus 3 into 1 by 4 plus 1. So how to calculate this? So this is 3 into 1 minus 1 by 3 by 4, correct. So this is minus 1 by 8 plus this is 3 into 2, this is 6 by 8, I can write this is plus 8 by 8. So this is equal to what? Minus 1 plus 6 is 5, 5 plus 8 is 13. So this is 13 by 8. Next, what is remaining? F of 4. So what is f of 4? So f of 4 is 4 cube is 64 plus 4 square is 16. 16 into 3 is 48 plus 1. So definitely if you see, this value is larger among all the values. F of 4, if you calculate this, what you will get? I'll get 113. So 113 is the largest value among all. So f of x attains its absolute maximum at x equal to 4. Absolute maximum. And where is the absolute minimum? So absolute minimum at, I think, x equal to 0. F of 0 is the smallest value among all. So x equal to 0 is the absolute minimum. So this is some preliminary concepts about maximum minimum. Next we will see about what can you say about the function from f dash. You have seen about maxima minima. We will see how you can identify whether your function is increasing or decreasing. So we'll see what does f dash say about f. We'll draw one graph. I will draw one graph here. So you can see this graph. So this is point A, this is point B, this is point C, and this is point T. So from point A to B, if you draw any tangent, it has a positive slope. If you from point B to point C, if you draw any tangent line, it has a negative slope. Again, if you draw from point C to point D any tangent line, it has a positive slope. So what does it mean? F dash x is greater than 0. Okay, from point A to point B, f dash x is negative because it has a tangent line has negative slope. From point B to C, f dash x is positive from point C to D. So in this way, from the derivative itself, you can identify the nature of your function f of x. If your derivative is positive in some interval, you can say that your function is increasing, and if your derivative is negative in some interval, you can easily say that your function is decreasing in that interval. We'll take one example on this also. Okay, this is whatever I have told, this is written here. If f dash x is greater than 0 on an interval, then f is increasing on that interval. If f dash x is less than 0 on an interval, then f is decreasing on that interval. So this is one of the example. You have to find about this function's nature with the help of derivative, that where this function is increasing and where this function is decreasing. So first of all, to identify, we will find the derivative of this function. So f dash x is what? F dash x is nothing but 4x cube minus 12x square minus 24x. So first you have to find the critical numbers. So this function is differentiable everywhere. No real is there for which your function is not differentiable. Okay, this is 12x cube. Okay, so 12x cube minus 12x square minus 24x. So this is equal to 0 in order to find the critical numbers. So if I take 12x common, this is x square minus x minus 2 equal to 0. So what are the values for which this function, this is 0. So x equal to 0. We can factorize this x square minus x minus 1 where it is 0. So x square minus x minus 2 equal to 0 can be written as x minus 2 and x plus 1. Okay, x square minus 2x plus x minus 2. So two more points are x equal to 2 and x equal to minus 1. So these three are critical numbers. These three critical numbers divides a whole real into 4 subintervals. So on that 4 intervals, you have to check the sign of these factors 12x, x minus 2 and x plus 1 in order to check whether your function is increasing or decreasing. So we will check the sign. So this is, you have to check the sign of this factor 12x. So x minus 1 and what are the factors? X plus x minus 2 and x plus 1. And what are the intervals? You have to split interval in this way: minus 1, 0 and 2. So first of all, you have to check for this interval x less than minus 1, then you have to check in between this interval, then you have to check in between this interval, then you have to check after this interval. So first interval is x is less than minus 1, then minus 1 is less than x less than 0, then 0 less than x less than 2, then x greater than 2. So this is, we are writing the sign of all the factors, and then we will write the sign of f dash x. So x less than minus 1, 12x is negative. You can easily verify. X minus 2 is also negative when x is less than minus 1. And when x is less than minus 1, what can you say about x plus 1? It is also negative. So negative into negative 3 times, f dash x you will get negative. So what is the nature of the function? It is decreasing on minus infinity to minus 1. Next we will check in this interval minus 1 to 0. So in this interval also 12x is negative, x minus 2 is also negative, okay, and this term is positive. So what you have got, this is positive, negative, negative, positive is positive. So your function is basically, because f dash x is negative positive, so your function is increasing on this interval on minus 1 to 0. Next 0 to 2, 12x is positive, okay, x minus 2 is again negative, x plus 1 is positive. So again you have got positive into negative, which is negative. So your function is decreasing on 0 to 2, and x greater than 2, 12x is positive, x minus 2 is positive, x plus 1 is positive. So again you have got function, your f dash x is positive, so your function is increasing on x greater than 2 means 2 to infinity. So with this simple application of differentiation, you are able to check whether your function is increasing or decreasing in whole real line. Okay, so thank you very much. We will again meet in the next lecture. We will again see some more real life application of differentiation. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.